Hello there, mathletes. We are going to go over a quick problem on using perpendicular bisectors of chords in a circle in order to find the circle's center. Hopefully you've had a time to read through this problem. It's about a crater that is in Mexico's Yucatan Peninsula, and we're trying to find where the center of the crater is to estimate its diameter. So we've been given a few points here, labeled in a coordinate system. Fortunately, we've been given 0, 0, which is going to be really nice for us. 34, 34, and negative 66, 22 are the 3 points that we're going to use. And like I said, having 0, 0 as one of our points is going to end up being pretty nice for us. I already have a worked out solution here that I'm going to kind of use as we go. So what I'm about to show you is not something that we're given right away. I just want to show you what our end game is here in this problem. We are going to try to find between those 3 points, and I've plotted them on this coordinate grid over here. I went by 5s in both the horizontal and vertical directions, so every 2 is 10. And I plotted the points. I just kind of, as best I could, plotted the points that I was given on our diagram over here. And our end game is we want to find the perpendicular bisectors of the 2 chords formed between these 3 points. So here's one chord formed between the points O and A. We're going to call the point at the origin O. And the other chord from the point B to O, or BO, I call it down here, and then here's the AO over here. We're going to find the perpendicular bisectors of those chords, because 2 perpendicular bisectors, or the perpendicular bisectors of 2 chords, I should say, will always intersect at the center of the circle. So finding the intersection of these 2 perpendicular bisectors of these chords will help us find that center there. So we're going to take this one step at a time. In order to find a perpendicular bisector, by definition, we need to know where the midpoint of this chord is. We're going to start with this chord BO, and we're going to first find that midpoint right there. Well, the midpoint is the average of the x and y values. So that's where this point 0, 0 comes in handy, because to find the average of 0, 0 and negative 66, 22, we basically are just dividing these 2 numbers by 2. If this wasn't 0, 0, let's say for some reason we were trying to find the chord from B to A over here, we'd add our 2 x values and divide by 2, and that would give us the x value of our midpoint, and we'd add our 2 y values and divide by 2, and that would give us the y value of our midpoint. But fortunately, we have 0, 0 as our point. So the midpoint between B and O is going to be negative 33, 11, which I've listed right here. We're going to call that point D. So D, we know, is negative 33, 11, and I have that written right here, but we can kind of see it. I'm going to just put it real quick right here. Negative 33, 11, that's that point right there. And we can find the slope of this line. Again, this is going to be really nice if we have 0, 0 as our point, because the slope is just going to be change in y over change in x, rise over run. Well, if one of your points is 0, 0, then it's just going to end up being the ratio of your y to x value. So we have 22 to negative 66, because 22 minus 0 is 0, 22 minus 0 is 22, negative 66 minus 0 is negative 66. So when you have that slope, okay, so that'd be going through all the work, which is really not necessary. This is going to simplify to 22 over 66, which is, negative 66, which is negative 11/33, and that's what I have right there. Okay, and actually we can simplify that one further to negative 1/3. But I just wanted to show you where that came from. That is the slope of BO. Why do we want that slope? Well, the slope of our perpendicular bisector, think of the word perpendicular. The slope of our perpendicular bisector then is going to be the opposite reciprocal of the slope of BO. So the slope of BO, we said, was negative 1/3, and it makes sense that it's negative, it's going down. The slope of this line, our perpendicular bisector, which I think I call DC later on here, is going to then be the opposite reciprocal, so positive 3. Okay, which makes sense as you look at this thing. It's not perfect, but this thing is going down. It's gradual, so it's negative 1/3. This one's going up, and it's steep, so it's positive, and 3, so that makes sense. So now we want to find the equation of this line here. The equation of DC, which is the perpendicular bisector of BO. So we're going to use our point slope form, which is y minus y sub 1 equals m times x minus x sub 1, where the x sub 1 and y sub 1 just come from some point. Well, the point that we have is our midpoint, that negative 3311. And our slope, make sure you use the correct slope here, is that guy. Okay, the 3, not the original negative 1/3 that we had, because we're trying to find the equation of this line, not the chord. So we have y minus 11, our y value, equals 3, our slope, times x minus negative 33 is going to become plus 33. And then we distribute the 3 to get 3x plus 99. And then we have to add that 11 over, and we have 3x plus 110. That is the equation of our first perpendicular bisector. Okay, we're about halfway done here now. We're going to do the same thing for our line, our perpendicular bisector over here. We're going to find the midpoint first, and again we have 0, 0 as one of our points. Thank you very much for the 0, 0 as a point, because that's going to make our midpoint easy. It's just going to be the average of those two values, or I should say half of those two values. So our midpoint is going to be 17, 17. Okay, and our slope of this line is 1, because the change in y or the change in x is just 34 over 34, which is positive 1. So the slope of this line, focused a little bit there, our slope of this line is going to be the opposite reciprocal. Well, the opposite of positive is negative. The opposite of, or the reciprocal of 1 is just 1. So that's what we have for the slope of our perpendicular bisector here. We want to come up with the equation of that line. So we have our slope, we have our point. Let's put it into our point slope form. Y minus y equals m times x minus x. Distribute negative x plus 17. Don't forget to distribute that negative to a negative to get a positive. And then we're going to add that 17 over to get our 34. Okay, so here's the main idea. We just found the equation of our two perpendicular bisectors, the two equations of these lines. We want to find where they intersect. So we need to solve the system between those two equations. To find the intersection of those two lines of DC and EC, to find our center, we're going to have to solve a system. So we have two y equals mx plus b equations. Now we could use elimination, where we line them up and multiply one of the equations by a value and add them together. But substitution here is going to be pretty easy, because we have y equals this, y equals this. We can just set what the y's equal, those expressions equal to one another, and solve. So we set the 3x plus 110 equal to the negative x plus 34, and we get our equation here. Added x over to get the 4x, subtracted 110 over to get negative 76, divided by 4, we get negative 19. We put negative 19 back into either one of these equations, doesn't matter. I'd probably pick that one. So we end up with y equals 53. Our center is at negative 19, 53. Let's go back up and take a look at our picture here and see if that kind of makes sense here. Negative 19 would be about right here, and 53, yep, that looks pretty good. Now remember, we didn't have this drawing to start with. You had a blank grid here. I was drawing this stuff in as I went. And I didn't draw the circle until, actually I did draw the circle as soon as I had my 3 points. No, I'm sorry, I take that back. I waited till I got my center. I plotted the 3 points, then I waited till I got my center, and then I grabbed the compass and I drew that in just to make it look nice. But until that point, I hadn't had my circle. I might have had like maybe a sketch in there of what I thought it looked like. Okay, we are almost done here. We have the center. Now we want to find the diameter of this thing. Think about how lucky we are now to have the origin as one of our points, because in order to find the diameter, we first are going to find the radius, and then we're going to double it. So you need to find the radius by finding the distance from this point to any point on the circle. And a lot of you right now are thinking, oh, let's do the distance formula, just like we had in class today in our section 9.3 when we were dealing with circles. We want to use the distance formula because we feel comfortable with it. But guess what? The distance formula we've talked today, is just the equation, the Pythagorean theorem, or the equation of a circle, which I'm not going to get into that because that's actually the section after this, but we really are just looking for the distance between this point and the easiest point that we can. Don't pull out the distance formula and start finding the why. You have 0, 0 as one of your points. So the distance between this point and this point is just going to be those values squared and added together. Okay? Because if you did x minus x, you'd have the 19 minus 0. Or actually it would be negative 19 minus 0, because our x value is negative 19. But the reason why I don't have a negative here is because I don't care, because I'm going to square it anyway. So a negative 19 squared and a 19 squared is going to be the same value. And then we have the 53 squared. We're going to add those together and take the square root. Please remember to square these together first, then add them, then take the square root, order of operations. We get 56.3. That's the radius. Can I put here using the distance formula? Really, it's basically using the Pythagorean theorem. We need to double that 56 point, I'm getting blurry here now, 56.3. We need to double that in order to get our diameter, so we got 112.6, and our units are in miles. So through a little bit of geometry combined with algebra, the solving of a system, we're able to find the center and then the radius and then double it to find out that our diameter is 112.6 miles.